CLDR. So first off, I work at Shutterstock in New York on the international team, where we internationalize and localize our web applications and services, as well as do a lot with multilingual search, as I was mentioning earlier at the lightning talks with, sorry, my computer went to sleep. So as I was mentioning earlier with the lightning talks and the multilingual stemming, and I've talked a lot at YAPC in the past about Unicode and characters, and most people know of... Dave brought my lunch. No worries, everyone. So...
Oh, I'm sorry. Okay, you're here now.
Thank you. So most people think, when they think of Unicode, they think of characters, and they think of things you can do with characters. But there's a lot more to Unicode than just characters. So yeah, characters, all sorts of characters from all sorts of languages, Egyptian hieroglyphs, all sorts of things I don't even know what they mean. Oh, my emoji isn't showing up, but yeah, there's a lot of hype over emoji these days. And then, you know, people think about things you can do with characters as well, like normalization. Here, we're normalizing this form of G to that form of G, and this Arabic character into that other one, which is multiple code points. There's a lot of things that the Unicode specifications say how to handle characters. And also, Perl does Unicode great. I've talked about a lot of this in the past, that Perl has the best Unicode support in the core out of any language out there. Excellent for regular expressions, excellent for handling grapheme clusters, and a lot of things that you just can't do in many languages. Say matching on Unicode character properties, any Unicode character property in the core regular expression engine. But today I'm going to talk about the CLDR, which is more than just characters. The CLDR is the Common Locale Data Repository. And this is like, say, traditional Unix locale data on steroids. It is a massive amount of data and standards for how to work with this data for all different languages, all different locales. And let me take a step back and make a differentiation here between internationalization and localization. So internationalization is building software, building applications that can support multiple languages, multiple locales, multiple countries. And localization is actually localizing for specific locales. So, for example, I could write a web application that could potentially support any language in different translations and different formatting, and just apply it in English. Well, I do have an internationalized application, even if, say, US English is my only locale. Or I could have a static website that I have translated into 5 different languages. Well, those are all localized versions of that website, but that is not an internationalized application. So internationalization and localization go hand in hand. First, you internationalize your software, and then, as you need to, you localize it into different locales. A locale, commonly, you could just perceive a locale as a language, but sometimes it is a set of different things, like a language and a country, because different countries use different languages, the same language in different ways, such as French, or Canadian French, and French from France. Even the script can change, and you have some countries using a different script for the same language. Take simplified Chinese and traditional Chinese. And at Shutterstock, we support 20 different languages, including Korean, Thai, Japanese, Chinese, a lot of Northern European languages, Hungarian, Turkish, and we have to deal with all sorts of locale data for this. And that's where the Unicode CLDR comes into play, because it makes it so we don't have to do as much research. We don't have to find out specifically how each thing should be formatted in these different languages and these different countries. Instead, we can just follow the standard, and we've been implementing a lot of open source software and releasing it to CPAN to help with using the CLDR. Because the CLDR, it's really just this two things. One, you've got this massive set of data. It's all XML data in a specific format called LDML, and then there's the specification to go along with it, which is a very dense specification saying exactly how you use this data. For some people, they might want to use, say, a CPAN library that implements parts of the specification and supplies the data for it. Other people, it's completely legitimate, even if there is a library available, not to use it and just take the pieces of data that you need. Such as, say, with I/O prompts. Well, you could have an I/O prompt where you type Y or N for yes or no. Well, obviously that's English, and if we're going to supply, say, an internationalized I/O prompt and use the CLDR locale data with it, CLDR provides yes and no translated into all different languages, as well as the individual letter that you would use for it. So in that case, you might not want a large module as a dependency with, say, 75 megs of locale data, and instead just pick the small pieces of data straight from the XML and use it from there. So that would be a legitimate use case. Or even using a module that supplies the data and then putting it directly into your application or module instead of requiring a much larger other module. So there are a lot of different ways that you can use the CLDR. And the most traditional way that's been around a while on CPAN is this module called locales. It's a pretty simple module, and you just, first you instantiate your locales object using a locale, which can be just a language like FR for French, or it could be FR-CA for Canadian French. Then it provides a bunch of different methods to retrieve locale data. Now, with this module, it's pretty minimalistic. A lot of it is just, here is the data I want, and here is what I'm receiving. But the CLDR specification actually has a lot about how you format data, and it doesn't provide much of that. So I'm going to get into that next. But here's an example of just requesting the language name of EN for English in the French locale. And there you've got English and French. And here we're requesting the territory name for US, and that's United States in French. Now, at Shutterstock, we sell things. We sell these subscriptions for stock photography and other stock media. So we have a lot of prices that we have to deal with, and we have it in all different languages and all different currencies. These display formats can vary drastically from different language to language and also from different country to country. This is one of the more important parts, to not just use language, but to use a full locale that includes a language and a country, because some countries would expect certain currencies to be displayed certain ways and other ones different ways. So here, for example, we've just got our English pricing page in US dollars. And here we still got US dollars just for these examples, but Italian, and you can see that we've switched over to periods for your grouping separator, and let's, the US dollar sign at the end there. Then a Russian here, where we have a space, a non-breaking space, as our thousands grouping separator. And here, what am I even looking at? Yeah, I think this is Norwegian. So here, I guess it would be more natural just to say USD. Let's take a look at how we powered this, because there was nothing implementing this section of the CLDR specification on CPAN. So I built CLDR number. And with CLDR number, first you instantiate your CLDR number object, and you pass in your locale. We're starting off with ES for Spanish. Now we're requesting a decimal formatter, just for decimal numbers. And formatting 1234.5, which in Spanish, this is what you'd receive for the default Spanish locale, with a space for your thousand separator and a comma for your decimal separator. But in Mexican Spanish, they actually do it like we would expect in English. So that's why it's important where if you are supporting Spanish in Mexico or in many other Latin American Spanish locales, it's so important to also specify the country in there. Because it just would not be a natural experience for someone from Mexico viewing these numbers. Here's Arabic. Arabic uses a completely different numbering system. It's still a decimal numbering system, but completely different characters. And actually, the thousand separator, I believe, isn't always, well, it's not always used in our numbers either, our Western Arabic numerals. But in these Eastern Arabic numerals, it's even a little less common. So you could, this is very customizable. You could turn that off, for example, by unsetting your grouping sign. Now, we get into Bengali, and things get a little different. It's not really a thousand separator, it's a grouping separator. Because in Bengali and a lot of Indian languages, the first group is 3 digits. And then each group after that is 2 digits. So you keep on going, it's 3, 2, 2, 2, and so on. This even supports, well, yeah, this supports setting a primary grouping primary grouping digits and secondary grouping digits. Then we've got a percent formatter. Here we're requesting a Turkish percent formatter. Because percents, a lot of people don't realize this, but percents can be displayed in completely different formats for different locales. So we want 5%. We pass in 0.05, and in Turkish, they flip the order of the number and the percent sign. They put the percent sign to the left of the number. And in Arabic, there's a slightly different percent sign altogether. That's a different character entirely. And in French, well, it's a little closer to English, but we put a space in there. And generally, in any of these formats, when you see a space, it'll be a non-breaking space, just because you don't want those two parts wrapping, one above and one below. You always want them to remain together. And this is a little lesser used, but there's even like a per mil formatter. And that's supported in many locales here. So let's get on to the currency formatter that I was showing you before in those screenshots. Here, we're requesting one for English in USD. It's very important you specify the currency when you are formatting a currency, because if you don't, I mean, what does this number mean? The number doesn't have any representation without both a numeric value and a currency. Because you can't just like take something that was expected to be in US dollars and then format it with Japanese yen without doing a conversion first. And this does not convert numbers. This just formats numbers. So let's format $9.99, very popular price. And as you'd expect, we receive $9.99. When you say just the EN locale, it defaults to thinking in US English. But now we specify Canadian English, en.ca. And by the way, this is the locales, how you specify them, it's case insensitive. You can use an underscore or a dash. You commonly see either one used. So Canadian English, and now it's formatting it as US $, because you need to differentiate it from Canadian dollars. And here we've got Canadian French. But as soon as we switch our currency code to CAD for Canadian dollars, well, it gets rid of the US there, because if you were formatting a dollar amount in Canadian French, you'd really expect it to be Canadian dollars. And here's that Bengali again, where we're setting the currency to Indian rupees. And you see those 322 grouping there with the local currency sign. Most people aren't even familiar with that currency sign. So let's see how we might use these in translations, because if you're localizing a site, you need a lot more than just formatting your numbers and prices in different ways. In fact, the main reason I'm so interested in the CLDR here is because most people, they start off with translations, but oftentimes you don't see nicely localized formats and dates and times and numbers and prices. So here let's get into some translations where the CLDR doesn't have anything to do with just random translations of text. It's only very specific locale data. What I'm showing you here, this translate function, that isn't anything specific. It's just for the sake of example. You might be using getText or makeText or an in-house translation system. But here what we're doing is we're calling our function for our translation system and passing in a string with placeholder values. So blank to blank of blank. What we want to see here is say 1 through 25 of 1,500. So then for our placeholders, we're passing in these formatted values for 1, 25, and 1,500. And then we get the expected results in English, 1 to 25 of 1,500. But there's a shortcut for this, because CLDR number supports ranges. And if you call the range method with two different numbers, a lower value and a higher value, although it doesn't really matter, you can send whatever you want, it's going to do CLDR formatting for this, because the CLDR provides range characters and what side each of the numbers should be on them. So we now just have two placeholders, one for our formatted range and one for our formatted total. So if we change this to Japanese, for example, the range character is the full width tilde. And this is very customizable. You can change the numbering system. Here we're changing it to full width, or it's specified as full wide in the standard. And now instead of the default, which is the ASCII Western digits for Japanese, we'll get the full width ones. Both of them are valid, but it's just up to what you want to use. And there's another way to specify that even in the locale code itself. This is an extension to the BCP 47 language tags, where at the end you specify -u-, which says everything after this is the Unicode extended language codes. And then you have key value pairs. NU stands for numbering system, and then full wide is the numbering system. Now, well, I guess first off, any questions about formatting numbers and prices? Okay.
How does it all get translated? All yes or no?
So that is expected to be translated from your translation system.
Okay.
Yes?
The word of, I guess, a special case.
Yeah, well, so the word of is not translated, that's not part of the CLDR. When we say this of that, that is, in this example, being handled by whatever your translation system is and by what your translators have supplied. So,
if that's the case, then, but the position could be reversed.
Yes, the position could be reversed. So that's what's important about that. Then say we have this these placeholder values where it's placeholder of placeholder. Well, your translators, they could potentially provide it, placeholder 2, some other characters, placeholder 1, depending on the language. I personally think that it would be great if the CLDR fully supported this example because it's such a common use case in user interfaces and search results and such. So that's something that would potentially be possible in the future with the CLDR. And I've recently joined the Unicode Consortium, and I plan on getting more involved with the CLDR committee. So that's something I'd love to bring up.
Sorry, one last question on that. Do you have an ordinal for anything, first, second, third? Is it going to deal with that too, or is that follow the translation stuff?
I haven't looked into ordinals with it. So.
Because we recently learned about some of the Eastern European ones that have different ones for 12 and 13 versus 2 and 3. So.
Yeah, so the question is about formatting ordinal numbers. And although I've used the lingua number modules on CPAN, I haven't looked into that as far as the CLDR goes. And the CLDR, it's a massive, massive spec and amount of data, and we're not going to nearly cover all of it today. But this gives you a taste for what's available, and especially what's available on CPAN right now, and what's being worked on CPAN. So Unicode Collate Locale, this is actually a module that is bundled with core Perl. Unicode Collate has been bundled with Perl for, I don't know, forever now, at least since 5.8. And I think it was in 5.14 that Unicode Collate Locale was also added in. And this provides localized collation, which covers sorting and comparison of strings and values. Because the sort order can change, and what character is in front of what character, or what string is in front of what string, will change depending on your language. And with this is pretty simple. We instantiated Unicode Collate Locale object. Here we're using PL for Polish. And then just sorting a list and returning our sorted list. It also has EQ for equality, and LT for less than, GT for greater than, and a bunch of different methods that you would want for localized comparison. And just for an example there, say your O with an umlaut, or umlaut specifically German, but O with diaeresis, that would sometimes come after an O, that would sometimes come at the end of the alphabet after Z, and that would sometimes be treated as OE and be equivalent to OE. So it can just vary depending on if we're talking about German or one of the Northern European languages, or even variants of German. And Datetime. Who here has used Datetime? Okay, almost everyone. Who here has used the CLDR-based formatting in Datetime? Okay, we've got two people. So a lot of people, when they format and specify like a format syntax with it, are using the more traditional formatting syntax. But CLDR also defines its own one, and that's supplied in there. I don't have a lot of use for a different formatting syntax. What I have use for is predefined formats for different types of values. Say you want a full-length date time, then the CLDR defines exactly what the format syntax is for your full-length date time. It may be, Y for the year, and so on and so forth, but it's a whole string that's a full format. Then say you want a narrow width date time for use in mobile devices. It has that as well, where it leaves off quite a lot of information, and it may be entirely numeric or abbreviated. Well, Datetime doesn't support these predefined full formats. Instead, it just knows how to parse them and provide your formatted date time using that syntax. But that's where Datetime Locale comes in, because it's a CPAN module that provides these predefined formats for, say, your full-length format of dates and times and date times and ranges of dates and so on and so forth, as well as your standard format, your short format, and your narrow format, where narrow can even be ambiguous in that, say, in English, T is for Tuesday and T is for Thursday, but it's sort of known because you're using it in a way where each one is available and you've got a very small device in front of you. So anyway, there's a lot of locale data for all of these different formats. In the latest version of the CLDR, number 25, just the core XML data was 76 megs. And that's why I've been implementing individual modules like CLDR number instead of focusing on one large monolithic module. But there are other projects ongoing out there which I'll show you. So here's an example with Datetime where first we're instantiating our Datetime object using our Japanese locale, and you set the locale attribute. What that actually does is that instantiates a Datetime locale object. And then your locale attribute, it doesn't just have your JA string, it has a Japanese locale object. So then I'm calling the datetime format full method from the datetime locale object stored in the locale attribute, passing it to format CLDR, which is core datetime, and then it provides this formatted full-length Japanese datetime. Now, one thing I have to say though about datetime and datetime locale is that this hasn't been updated for recent versions of the CLDR. Datetime locale is about 5 years behind right now, and that's really just because it needs someone to work on it and implement these features. The CLDR can change a lot in between major versions, and it can be very cumbersome to update modules to support those. So one project that I'm taking on is updating datetime and datetime locale to
support CLDR version 25, and it's a pretty big project. If anyone else wants to get involved with it, I'd be happy to have help with that. And as far as sort of single implementations of the whole CLDR spec goes, there's another project ongoing by a British Perl hacker, John Imrie, called Locale CLDR. And the first release to CPAN was actually just a few months ago. And this project attempts to just implement everything. It originally was released with Perl 5.18 requirements using experimental features, which meant that, well, I'm using systems a lot older than that. I'm using 5.16, for example, and I'm even still using 5.8 systems, just because, well, I have to in certain environments. So that meant I couldn't really use this software, but I'm very excited about it because it has a lot of functionality implemented, and in one of the recent releases it bumped the required Perl version down to Perl 5.10 except for the text transformation, which is using the new experimental feature of Unicode or the extended character classes in regular expressions. So you do have to have Perl 5.18 for that, otherwise Perl 5.10. But as I said, I'm still using some 5.8 systems as well. So I'm trying to help out with this project where I can, but it's mainly something that I think this one developer over in the UK is working on. The project that I started up is Perl CLDR, which is, you can check out Perl CLDR on Twitter and Perl-CLDR on GitHub. There's our website, perl-cldr.github.io, where we have all the projects that I've been working on recently. Some of the ongoing things or ones that are planned are, as I mentioned, Datetime locale. There's CLDR transform. This is for transforming, transliterating, transcribing different writing systems from one to another. It could be from hiragana to katakana, from katakana to hiragana, from even just like full Unicode Latin to ASCII. And the CLDR defines all of these ways to transform text. So what I really want to have is a lightweight individual module to do this, because I want to use it in more lightweight applications and services where I don't even need any more locale data. I don't need to format dates or times or anything like that. And then another related module that I've started up, and both of these I've got some code for already, functionality working in it, is a CLDR segment for text segmentation, localized text segmentation specifically. So segmenting into tokens on different levels, say on the character level, because some languages consider, say, CH to be one character in the language. So if you want to split on characters, well, doing a localized split, and in some cases you might have CH as a single character that you're splitting on. Then there is also word segmentation, so determining algorithmically what is a word, and that is very important for doing search, because say we're indexing text and we want to break on each of our words and index them, and then also search on each of those words. Then there's also line segmentation and sentence segmentation. One other module is I'd like to get a standalone module out there to handle just the locale codes alone, to parse a locale code and provide all of the information. So your language, your optional script, your optional country, and then all of the Unicode extended key value pairs, like your numbering system, your calendaring system, are you using the Buddhist calendar, and so on and so forth. And then other modules, including these ones, including CLDR number, would just require that to parse their locale codes and not have to have all of this logic that they currently have for parsing locale codes and using that data. And one thing before I get on to questions is I want to mention what other language communities are up to with the CLDR. So the best implementation of the CLDR is ICU. That's the Internationalization components for Unicode. It has a C version and a Java version. Unfortunately, though, there is no there's no wrapper for ICU for C. I would love to see this in Perl. I know a lot of people or some people who are into Unicode and Perl aren't a big fan of ICU because it works on UTF-16 natively instead of UTF-8. So you would have to convert from UTF-8 to UTF-16 and back again. Of course, a wrapper could do that, but it's extra conversions going on there. I think if someone wanted to take on that project, I know someone did about a decade ago and it hasn't been updated since, and it wasn't ever on CPAN. If someone wants to take on that project who's a C and XS programmer, that would be the most valuable thing to have. Even though I think there's still a lot of value in small, pure Perl-based implementations of just individual portions of the CLDR.
Then some languages, like Python and PHP, they provide wrappers for the ICU for C. So for example, with PHP, there's the international module, which is core as of PHP 5.3. And if you're a PHP programmer, that's actually pretty exciting because you've got sort of a lot of the CLDR at your fingertips just by installing the language. And you know, Perl is the best language with Unicode support out there. It's not the best language with CLDR support out there, and I think this is one of the most important areas for the Perl community to improve on, so we can write internationalized web applications that supports all of the world's locales that are defined by the CLDR. Some languages like Ruby and JavaScript have attempted to do one large implementation of the CLDR. So Twitter CLDR is what you would use on Ruby or JavaScript, including if it was straight up JavaScript or with Node. And that is all maintained by Twitter developers. It has a lot of great functionality in it. It supports a more limited set of locale codes. Most of them are just on the language level and not on the language and country level, which is sort of limiting when it comes to formatting, say, currencies, or even just numbers in Mexican Spanish versus Peninsular Spanish. But this is an exciting time for the CLDR because many of these projects are pretty new and are becoming larger projects, and I look forward to working more with the Perl community via Perl CLDR on Twitter and GitHub to implement a lot more of the CLDR specification and locale data. So any questions?
How much of the code that you talked about is generated from the XML? Do you parse it when you make the module? Or?
Yeah, so with CLDR number, what I do is I wrote a script to parse the XML and to generate just Perl modules for it.
Okay.
And with locale CLDR, that's what they're doing as well.
Have you worked with the JSON version of the data set?
So there is a JSON version. The CLDR official releases do not have JSON data, but there was so much desire to work with JSON instead of XML. Because so many languages, that's just what they do nowadays. That's the default data interchange format. And there is an official tool to convert the XML to JSON, not the whole data set. You specify with the tool what you want, and then you just dump out these JSON files with what you want. That's what they use with some of these projects. The tool is a little hard to use, actually, but I know they're working on making it more user-friendly. With the Ruby project, for example, they convert it to YAML, and they distribute the locale data as YAML. Yes?
How does the CLDR handle unusual language and territory combinations? For example, the company I work for has an office in the Netherlands that want all the user interface in their own language. But for international use, they want all the numbers in the US formats.
Well, so first off, one thing about the locale code parsing is that you do not have to, I would say with CLDR number, you don't have to supply a locale code that is defined in the data. You could say AR for Arabic -US. And there's no American Arabic locale data defined. But that just means that it will fall back to Arabic, which uses, I think, just the modern Arabic. And the fallback system takes into account the specified language and script and country. Then
the default formats, you don't have to use them as is. Say with CLDR number, there are methods so you can further tweak them to your needs. Say you don't want the grouping separator, well, you could remove that. Or say you want to only use the grouping separator when you have more than 4 digits, because the Chicago Manual of Style says don't use a grouping separator if you have 4 digits, but use it if you have 5 or more. Well, you could say write a wrapper around it that does that additional logic for you and calls the defined methods in CLDR number. Anything else? Okay, well, thanks everyone.